Okay, so it's the process management that we have to discuss. I think I have briefed some of the things for you, like when we are stopping the things like week before, right? But I'll start it from here and do some recapping part. Then we can flow with the lesson, right? So process management is one of the service or one of the managements that the operating system is providing to the computer, right? So like we discussed earlier, we discussed about the storage management. We discussed about some other resource managements, right? So likewise, process management is one another management, and according to our syllabus, this is the most important part of the lesson, right? Because most of the questions that is given to you regarding the operating system, it is on this section, right, which is the process management. Later, you will find the memory management part, which is a calculation related section. That is the other section that you are going to get the questions from, right? So process management is about how operating system is managing the processes which is happening in the computer. And I told you, now generally we are storing or installing the programs into our hard disk, right? So later, once we execute the programs, processors will be created, right? So like I said week before, when the program is in execution, you can find the processors. So I have shown you the place that you can look into these processors, which is the task manager, right? So in the task manager, so these are the processes which is carried out by the operating system. So in my computer for the moment, there are many different processors and services are being carried out. Now, not all these programs or processors are related to the user related programs, right? So if I minimize my task manager from using this arrow fewer details right over here, right? If I minimize it, so then you can see what are the things that I am running, or like what are the things that they are for me to help in this computer, or the user started programs, right? So Adobe Acrobat Reader, the HP Pen Control, Whiteboard, and Zoom Meeting, right? Those things are there, right? But when I go for the more details part, this will shows you the user created processes as well as the processes which is created by the operating system. And you can see comparatively the operating system processes are huge when you take with the user processes, right? So all these processes are related to some of the programs which are being executed for the moment. So now you can have the idea that we can, like an operating system is capable of running many different programs together, right? Which we call that the multi-programming ability, right? So many different. Now, if you look this closely, you can see like desktop window manager is something like that is there, window Zoom meeting is there, client server runtime processors kind of things are there, right? So some Adobe collaboration synchronizer kind of things are there, and there will be some processors which are which exist on the same name, right? So if you look into this comms arrogate and console window host, right? Device association framework provider host, Google crash handler, Google input tools, right? So there are things which is happening under the same name. So that means one particular program is capable of creating many different processes, right? And once you move to this performance tab inside the task manager, you can see how my computer is performing. This is how my CPU is being used, right? So it has 100%. So like almost 25% kind of a portion is used by the CPU for the moment. And if you think about the memory, so memory, I've got 8 GB memory with me. So like 4.6 GB memory is used and it is constant, right? And regarding the disk, that means the hard disk, it's not very much being used for the moment. This is about the internet usage, the Ethernet, and this is the GPU, graphical processing unit, and how it is being used. And I got 2 GPUs actually, which is a dedicated graphical processing unit and the onboard graphical processing unit, right? And I want you to have your attention to the CPU workings. මෙයා ඇතුලේ තමයි CPU එක ඇතුලේ මොකද වෙන්නේ කියලා පෙන්නන්නේ. Right? So look at these details. I've shown this to you on the last session as well. So it shows you the utilization. It shows you what is the speed that the operating system is, the CPU is working. And look at this part. This indicates the processors. 237 processors are there. And look at these threads. Now, threads means a particular process will be divided into smaller process again, right? So that small process is called a thread, right? So regarding these 236 processors, there are 2090 odd process, 2900 odd processors, and this handling part is indicating how these threads are being handled. Then thread එකක් handle කරනවා කියලා කියන්නේ it is like අපි අර ඔගොල්ලෝ රූකඩ දැකලා තියෙනවනේ නේද? රූකඩ වලට threads වලින් තමයි යාගේ නේද? අත ඔළුව කකුල් connect වෙලා තියෙන්නේ. So අපි අතට අදාළව තියෙන නූල හෙලවුවොත් තමයි අපිට අත හෙලවෙනවා පේන්නේ රූකඩේ. Right? So same thing happens over here. So operating system has the control over all the threads that is being considered for the moment, and those threads will be handled in a very fast manner and in a separate way. So these handles indicate how many times or like in which frequency that we are going to handle these threads. Right? එකම thread එක කීප වතාවක් handle වෙන්න පුළුවන් just for a single second. Right? And you can see if you look to this right hand side details, the base speed is given 2.11 gigahertz, right? That is the processor capability, right? So the base speed means like the optimal speed, right? Like so the CPU is capable than that, right? So the optimal speed is given like 2.11, and just one socket, that means one single CPU is there on my motherboard, and there are 4 cores. There are 4 specific places where the CPU can do the processing, right? And logical processors කියන එක software based concept එකක්. So even though there are 4 physical cores, that 4 physical cores are working as 8 different CPUs. That is what they have mentioned over here. Logical processors are equals to 8. Now these things are not for you to remember, just to understand, right? So virtualization is enabled. That is another facility which is given by the operating system. And the look at these L1 cache, L2 cache, and L3 cache. We talked about these things. when we are talking about the hardwares, when it comes to the memory types, there are registry memory, there are cache memory, there are main memory, which is the random access memory. So then I told you like the cache memory is divided into 3 levels, which is L1, L2, and L3. So you can see the specification of L1, L2, and L3. L1 is 256 kilobytes big, L2 is 1 MB big, and L3 is 6 MB big, right? So those kinds are there. So what we really need now is the process and the threads for the moment, right? So now here in this node, it is been illustrated graphically, like when program is not in execution, you can't see any processors. When a program is in execution, you may see one or more processors regarding that. Okay, now these are going to be new things. Now these processors, kriyawali කියලා අපි සිංහලෙන් කියනවා, right? These processors divide into 2 types, which is IO bound process and the processor bound process. නැත්නම් CPU bound process කියලා අපි කියනවා, right? So these names are given to the processors for a reason. Because there can be processors which are executing in the speed of, or like relatively with the speed of the input-output devices, like CD-ROMs, like keyboard, like mouse, right? Those processors depends on the hardware, that particular input-output devices, right? So it has its own speed, right? And definitely, it is not fast as the CPU bound process or the processor bound process, because CPU is the component which has the highest speed in the computer, right? So it's the fastest. So if processor is working at some speed, so there are some process kriyawali which is processing relating or like relative to the speed of the CPU. So they are comparatively very fast, right? They are trying to match the speed of the CPU. So those kind of process are called processor bound process, or like the CPU bound process. Rest of the things, they are depend on the input output devices. They are called IO bound process, right? So when it comes to the operating systems try to put both kind of processors in the RAM and try to synergize the things inside the operating system, right? So yeah, people, did you got the concept? IO bound process are there, processor bound process are there. Is that clear?
So about explain that.
හරි ඉන්න. ඔක මම තව පොඩි දෙයකින් ඔයගලන්ට පෙන්නන්න හිතාගෙන හිටියේ මම කරන්න ඉන්න presentation එකකට relatively, right? ඒක මම පෙන්නන්නම්, ඒකෙන් ටිකක් වැඩිපුර clear වෙයි වැඩේ, right? Now this presentation is not published yet, people, so it is about to publish again. Recordings වලට තාම ගිහිල්ලා නැති ඒවා, right? මම ඔයගලන්ගේ note එකෙන්මයි ඒක හදලා තියෙන්නේ, right? So we know about this. So these are the types of process, right? So like processor bound process and the input output bound process, right? So this is the input output bound process, as I told you, right? So it is with the time, or like with the time period, or with the speed of input output device. So input output device take much longer time to process things, right? එතකොට මේ හැම කෙනෙක්ම process වෙන්නේ CPU එක ඇතුලේ but එයාගේ speed එක depend වෙනවා sometimes on the process, that means the CPU, sometimes on the input output device. So when the process depends on the input output device, it's going to take more time to execute, right? When it comes to the processor bound process, right, it takes less time to execute, right? So things will happen quickly with the processor bound process. Things will happen slowly with the input output bound process, right? And yeah, Nirmana, clear deka? Right. So then we are talking about what are the needs, or like what do we want, what actually a process need to exist inside the operating system. It needs an ID. It's always given an ID from the operating system to identify what process is this. Then there will be executable codes, right? So each and every process need an executable code. Otherwise, like no point of having a process. The program එකක් කියලා කියන්නේ අපි ඉස්සරහට ඉගෙන ගන්නවා, it's something that we have written to get understood by the computer, right? So there should be some executable code, which means a thing which is made out of ones and zeros. So the computer or the process will be able to execute that. And then it may need the data. Sometimes those data is taken by the users, or sometimes the data will be referred by some other files in the computer. However, the data should be there for a particular process, right? And again, there is something called the context, right? So in that context, it involves many different things. We say there is a register called PC. PC stands for program counter, not the personal computer here, right? When it comes to the process management, PC indicates program counter, right? And then there will be priorities. Who is going to execute first? What is your priority to be executed? So එක processors තියෙනකොට එක process එකට වෙන වෙනම priorities දීලා තියෙනවා. ඒක හරියට ළමයි පේලියක් පෙළදස් කරලා තියලා එක්කෙනෙකුට කියන්නේ අපි හිතමු මොකක් හරි සෙල්ලමක් කරන එකක ළමයි පෙළදස් කරලා තියලා කියනවා කවුද මුලින් යන්නේ කවුද ඊළඟට යන්නේ. So those are called the priorities, right? So likewise, when it comes to the process management, processors need priorities, right? For according to that priorities, they will be sent to the CPU for the execution, right? So those details are called the context of a process, right? So those four things needs to be there, right? And then, yeah, I'll go to the note since this is on Sinhala. So next one is talking about how a process can be created, right? So now, how this process can be created. Now, there are several different things that a process can be created from, right? So one thing is you can have a new, not actually you, operating system can have a new batch job, right? The new batch job means inside the operating system, there are data which maintains as a batch. කණ්ඩායමක් විදිහට තියාගෙන ඉන්න ඒ කණ්ඩායම් operating system එකේ උවමනාව මත. The need of the operating system, some batches are being executed. So if a new batch is starting to do something, that means new process will be created, right? And then when user starts a program, definitely, if you just take the mouse and double click on something, so that means you are executing that program. So executing a program will create new process, right? And here always create a process to provide a service. Now, working with a batch and working with a service is two different things, right? So they are considered as two separate things. Batch එක කියලා කියන්නේ already හදලා තියෙන, sometimes it may need for some other programs to execute. So those kind of things. Services are not like that. Services are something else. Like you can give several different services, right? Like disk defragmentation, right? Many kind of services are there. So those services like the Ethernet service, like the Bluetooth service, those kind of things will be there. So if those type of a service is initiated or started, so then again, a new process will be created, right? And the next one is like the running program starts another program, right? So running program can give another program. It's like this. Now, when you need to watch a movie in the computer, you have to start the media player, right? So starting the media player is a particular process, right? So like assume that you are watching the movie using a DVD. So that DVD needs to be read by the CD-ROM or the DVD-ROM, and then it needs to be loaded onto the movie, the media player, right? So that movie is going to be another process. So media player කියන process එක අපි කියනවා parent process එක කියලා. In that process, on that process, many other sub-processors can be taken out. You can play a song, you can play a video, right? You can play an animation, kind of things are there, right? So those are called the sub-programs or the other programs, right? So it is like the fourth point. Running program starts another process, right? So those will be the reasons for a process to be started. And what are the reasons for the termination, right? So now termination, there can be normal termination, right? So the normal termination means what? The program will start and do what is what the program is supposed to do, what the process is supposed to do. Then their task is done. So the program is going to close. So that means when the program is going to close, the processes will be terminated as well. Because, you know, when a program or like when something in execution, then only the processes will be created, right? And sometimes some programs are terminated due to the lack of resources, right? දැන් ඔයගොල්ලෝ CD එකක් CD-ROM එකට දාන්නේ නැතුව Windows Media Player එක play කරොත්, then it is going to give you an error, right? ඒක Windows Media Player එක තමයි specifically ඔය වැඩේ කරන්නේ, right? So it's just it won't allow you to play anything and saying that there is no disk inside here, so we can't play anything for you. සමහර වෙලාවට ඔක ගොඩක් වෙලාවට ඔයගලන්ට දකින්න පුළුවන් when you don't have any audio devices fixed to a computer. Now if you take a laptop, it has built-in speakers, right? Like think about a desktop. It's just a system unit and a monitor. If you have not plugged a speaker or a headset into it, Windows Media Player will not allow you to play the music via the Windows Media Player. It will keep sending you the message. Sound out is not being connected, so we can't execute the program, right? So because of that particular program can be terminated. So the required resources are not available. And sometimes we may feel like programs may face with the execution errors. Then ඔයගොල්ලෝ Python ඉගෙන ගන්නකොට 9th lesson එකේ we always do a task called compiling and the running the program, right? So when you are run the program, if the program is having some problems, some errors, so those will be considered as the execution errors. So due to that, it cannot be execute further than that, right? So the program will be terminated. So those are called execution errors. Kriyatmaka vීමේ දෝෂ. Right? And sometimes parent process is being terminated. Due to that, some other process, the child processes can be terminated. Like the example that I took earlier. ඔගොල්ලෝ Windows Media Player එකේ හරි මොකක් හරි media player එකක movie එකක් බලබල ඉන්නකොට you know that you can stop the playing of movie by pressing the stop button. Stop button එක press කරොත් movie එක stop වෙනවා. But Windows Media Player will not be closed. But if you close the Windows Media Player during the when the movie is running, so both Windows Media Player plus the movie, both are going to end, right? So the parent process is the Windows Media Player, so it is being terminated. Because of that, the movie is being terminated. The process regarding those will be terminated, right? And you can take another reason, which is for the timeout situations, right? Or like the execution time limit exceeds, right? දැන් ඔය වගේ දේවල් ඔයගලන්ට එක්ස්පීරියන්ස් කරන්න පුළුවන්. සමහර programs on කරනකොට උවමනාවට වඩා වෙලා ගන්නවා එයා on වෙන්නේ. Due to some reason, right? So then what the operating system does is it recognizes this program is getting a lot of time to execute. So there should be some problem, and then because of that, operating system tend to terminate that. All right. So those kind of reasons can be there for the termination of a process. Right. Okay, people. Is this clear? Can I have the confirmation, everyone? Any questions? Right, great. So you are always open for the questions, right? තේරුම් නැති වුණොත් අනිවාර්යෙන් තේරුම් නැහැ කියලා කියන්න. Since we got newcomers කියලා කියන්නේ net me newcomer නෙවෙයි. Net me මං ගාව හිටියා මාත් ඒ O levels කරනකොට, right? But net me's friend is a newcomer, so if you got a problem though, if any place is not clear with you, you can always ask the questions, right? It doesn't matter that I have briefed it earlier or now or whatever, right? Okay, so moving forward, people. So now we know how to start, like in which scenarios that a process can be created, and in which scenarios that a process can be terminated, right? So now there is something called interruptions, which you need to understand. And again, with the interruptions, you have to learn how the interruptions are being handled. Now, literally, interruption means an interruption, කරදරයක් නේද? බාධා කිරීම, right? So why the interruptions are there in an operating system, right? Operating system එකේ CPU එකේ, like you assume, like inside the CPU there is a program running. Now I have shown you like 4 diagrams, like naming like 1, this one is 2, this one is 3, and this one is 4, right? So in the first square, in this first section, it shows you that the program called the program 2 is executing inside the CPU, and program 2 needs some resources from the input-output device. In this case, actually from the CD-ROM, right? So when program 2 needs something from the CD-ROM or from a CD, program sends a signal requesting for those inputs, right? So program won't be able to execute inside the CPU until the requested resources are given to it. And even though that we feel this is a very small amount of time, when it comes to the operating system and when it comparing to the CPU speed, it is a huge amount of time, because CPU will execute, CPU is capable of executing billions of instructions per second. එතකොට තප්පරයක් පරක් වෙනවා කියලා කියන්නේ මොනවාද? බිලියනයක් instruction execute කරන time එකක් එයාට loss වෙනවා. So it's huge relative to the CPU. So for some reason, if a program is going to wait until something is given by the input device, operating system will swap that particular program who is waiting or who is idling in the CPU onto the RAM, as this second diagram shows you. And then operating system will choose some other program which is ready to run, put that particular program in, load that particular program into the CPU and allow that particular program to run. So in this case, when the program 2 is taken out from the CPU, program 3 is given the chance to run, right? So still that input-output device, in this case the CD-ROM, is processing what is being requested from the program 2. So in the third diagram, in here this shows now the input-output, the request is completed. So he is ready to give the things. And when it is ready, it sends an interruption signal. Now this is the place where we find the word interruption, right? So this interruption signal is sent to the CPU by indicating, okay, I am ready. Someone inside you requests something from me, so I'm ready to give that now. CD-ROM says as an input device, right? So then operating system is notified with this particular situation, right? So operating system can see, okay, now CD-ROM is ready to give things to the program 2, and then after, operating system will allow the second program or the program 2 to get executed inside the CPU again, right? So that is the whole process, what is happening, right? So interruption happens in the third diagram. මෙතනදී තමයි interruption කියන එක එන්නේ. So what we call, or what we say as an interruption handling is the process that we can see in these 4 situations. So it describes why the interruption happens, why the process are being swapped, and how the interruption signal receives by the CPU, and how the operating system respond to the particular interruption signal. And again, remember, like once, operating system is not instantly going to respond to the interruption signal, right? It can ROM එකෙන් කිව්වම හරි මම දැන් ලෑස්ති මගේ දේවල් දෙන්න පුළුවන් CPU එකේ ඉන්න කෙනාට කියලා කියපු ගමන් operating system එක change කරන්නේ නැහැ. ඇතුළේ ඉන්න කෙනාව RAM එකට දාලා RAM එකේ ඉන්න කෙනා program 2 කියන කෙනා ආයිසරක එකපාරට CPU එකට ගන්නෙ නැහැ. එතන එහෙම switch කරන එකට අපි කියනවා context එක switch කරනවා කියලා. Later we are talking about that context switching as well. So to do this switching, operating system considers many different factors, right? So we'll talk about that when the context switching is there, right? There I'm going to explain it again. These are the things that the operating system is going to consider due to a switching, right? But interruption handling happens like this. The interruption signal operating system knows, okay, I can give the chance to the program 2 again in the CPU because whatever he is being requested, now it is available to provide. Or now it is ready to provide, right? So later, when the OS got the chance, it will start the program 2. Now, when you are hearing this story, you may get some questions. So if this happens in this manner, so sometimes a program is not going to execute. So stuck. Yes, we won't feel that, right? Over the computer you may feel this, right? I got the experience, right? And I know when I am like back in 2000s, yeah, like 2000, right? Like 20 years back, right? When we work on the computers, if we are doing something on the Word document, if we play a particular song, sometimes song is pausing or like stuck in for a second or two, right? Can I pick again? Stuck with me. I have experienced that. But nowadays, you won't be able to experience that kind of things because the hardwares are that advanced these days, right? So the laptops and all these devices are being made to not to give any hassles to the user. They just feel that everything is fine, but inside it, operating system and all the CPU, RAM, and everyone is like working as hard as they can to provide a better service to the user. Okay, people, are you clear with what is an interruption and how it is being handled? Yes, can I have the confirmation? Okay. Right, great. Now, next one is pretty important. The process management, and I'm going to talk about the process management with this particular diagram. So I'm going to take it from my presentation, right? So let's see how we can talk about it, right? Now, people, now when it comes to the process management, I'm just referring you to this particular diagram. I want you to show this thing. So now when there are a lot of processes for the operating system to handle, the operating system will be on these questions, or like will be on these situations. Like the operating system have to figure out which process that I'm going to send to the CPU, because CPU can take one process at a time, right? And to which time, when I'm going to send this, right? And for what time period that I'm going to send this process to the CPU. So those are going to be the major questions that the operating system is going to have, right? So to do that, operating system is maintaining some particular states regarding the processes, and again it will maintain the priority list regarding the processes, right? State maintain to recognize which state that this particular program is going to be, right? And then it maintains a priority list. Who is going to go first and who is going to go next, like that, right? So now we know when a program is in execution, it will create the processes, right? And these processes, once the processes are being created, it is given the state which is labeled as new. So they are in the new state, right? අලුතින් හැදෙන process එකේ තත්ත්වය කියලා අපි කියනවා state එක. They are in the new state, right? So when this new state are there, so we consider new state is a very spontaneous state, right? ඉක්මනට ඇති වෙලා නැති වෙන state එකක් කියලා අපි කියන්නේ. So when new state is given to a particular process, at that instant, it is being moved to the RAM, right? So once it is being moved to the RAM, it is changed, or like operating system is changing the state from new to the ready, right? So now the process are in the ready state. So the program එක start වෙච්ච ගමන් process එකට new කියලා state එකක් හම්බ වෙනවා. Then after it will admit to the random access memory or the main memory. Then it is said it is having the state as the ready state. Sometimes we call this the waiting state as well, right? Ready state එකේ හරි waiting state එකේ හරි ඉන්නේ. Like if you consider like a typical computer, most of the processors are in the waiting state, right? මොකද programs execute when there will be processors, so they will create and quickly move into the RAM, and it is given the waiting state. So when a particular processors are in the waiting state, are having the waiting state in the RAM, one of these processors, due to many reasons, given a state called running, and it is given the state called running just before it is moved to the CPU, right? Like at the instant when like at the point that it takes the running state, it will move to the CPU, right? So earlier it was in the RAM. P1 got the running state, then it is quickly moved to the CPU, right? So now it is in the CPU and it is running, right? So the state is running, right? ධාවනය වන කියලා අපි කියනවා, right? So then due to a timeout, right, a particular process is given some particular time. So due to that timeout, it can be moved again into the RAM. So timeout can happen, like timeout can be happen due to many reasons, right? Sometimes like if you think about a time sharing system, time sharing system each and every process is given a specific time period, right? Particular time period to run inside the CPU. So if you can done your work within that particular time period, then you can terminate, that particular process can be terminated, or else it has to come to the main memory and should stay in the queue, and then later it will be given another time to run inside the CPU, right? So for those reasons, if the time is out, it will be moved back to the random access memory or the main memory, and the state is again given as ready, right? Okay, people, is it clear up to this point? It is talking about the creation, it is talking about having the waiting state, and one of those will be chosen to run, so it is given the running state, and when due to a timeout, it can be moved to the main memory again and will be denoted with the ready state again. Is that clear, everyone? Right, great, brilliant. Okay. So now there are many other things that can happen, right? So yeah, now when a particular process is on its running state, right? අපි අර කලින් කතා කරපු දැන් waiting වෙලා ඉඳලා දැන් කෙනෙක් run වෙවි ඉන්නවා, right? So when it is running, if the execution is done, then it is going to release, right? That means the task for the process one is done. So once the task is done, there is no reason for the CPU to keep that process inside it. So it is quickly releasing the process. Once a process is being released, it is given the state called terminated. So now we know 4 status that a process can take. At the beginning, when it is created, it is given a new state. When it is moved into the RAM, it is given the waiting state. And when someone is chosen to run, it is given the running state. And when the running is done or the execution is done, it will be released. So that particular process is given the terminated state, right? So if a particular process running inside the CPU, and if due to some particular input-output request, like we discussed in the interruption handling, in that point, I told you that this process is going to be idling inside the CPU, like staying doing nothing inside the CPU. So operating system does not like this. Operating system always try to utilize the CPU at its maximum. පුළුවන් උපරිමයෙන් CPU එක ඇතුලේ දේවල් ක්‍රියාත්මක කරන්න තමයි operating system එක බලන්නේ. So if someone is like waiting to take something from someone or some input output device, then quickly the operating system will attend to this situation and will take the particular process and send it to the RAM again. The reason is because it is waiting for input and output, for input or output. So due to an input and output, wait, the running process can be sent to the RAM again. So you know, like when a process is running inside the CPU, it is having the state called running. And when it is moved to the RAM, it is given the state, a new state is given, which we call blocked. It is not going to be ready. Why it is not going to be ready? Because this process was moved during its execution, right? මෙයා CPU එකේ run වෙවි ඉන්නකොට මෙයාට ආවා input output wait එකක් එයාට දෙයක් ඉල්ල ගන්න ඕනේ. එතකන් එයා වැඩ කරන්නේ නැහැ. So operating system will put it inside the RAM and give some other to run inside the CPU. But the state of that process is going to be something else, not waiting. Yeah, waiting නෙවෙයිනේ. run වෙවි ඉඳලා මග නතර කරපු එකනේ, block කරපු එක. So that is why this particular process is given the state which we call blocked, right? And then now when there is a blocked program or like blocked process inside the RAM, and there are some waiting or like there are some processors which are having the ready states as well, right? So now this kind of a thing can happen. This is called suspending, right? Suspend කරනවා කියලා කියන්නේ නේද? පොඩි කාලයකට නතර කරනවා කියලා කියන්නේ. So this kind of process is going to take place due to the crowdness of the RAM. right? RAM එක ඇතුලේ මේ processors වලින් හැදිලා තියෙන traffic එක නැත්නම් crowd එක ඒගොල්ලන්ගේ crowd එක ගොඩක් වැඩි නම් computer is eventually tend to be slow, right? So when the RAM is getting crowded, computer is getting slower. Operating system does not like this because it will affect on the user. User will frustrate, right? නේ අපි කොච්චර අකමැතිද නේද? දෙයක් හිමින් වෙනකොට නේද? YouTube එකේ වීඩියෝ එකක් දාලා ඒක load වෙවි ඉන්නකම් load වෙනකම් අපිට ඉන්න බැහැනේ. Right? That's the human nature. Right? So likewise, if the RAM is being crowded, your computer is going to be a slower one. So operating system as a tactic to not get the computer slow, it will take some part from the hard disk and it will vacant some particular part of the hard disk, which we call the virtual memory, and send this blocked processors into the hard disk. Right? ඇයි එහෙම යවන්නේ? To free up the space of the RAM. මොකද දැන් අලුතෙන් programs හැදෙනකොට ඒගොල්ලන්ට එන්න තියෙන RAM එකනේ. So RAM එකට එන්න බෑ RAM එක crowd නම්. එතකොට දැන් මේ block වෙලා ඉන්න කෙනා ඇත්තටම run වෙන්නේ එයාගේ IO එක complete වුණා. ඉතින් එතකන් එයා RAM එකේ නොහිටියා කියලා ගැටලුවක් නැහැ. So for that reason, this one is moved, the blocked one is moved to the hard disk, right? Ek hard disk eකට move වෙන්නේ virtual memory කියන concept එකට අනුව. We are going to talk about the virtual memory as well, right? So දැනට ඔළුවේ තියාගන්න it is moving to the hard disk or to the virtual memory. So once this is been moved to the hard disk or to the virtual memory, the state is going to change. So then it will be given a state swapped out and blocked, right? Because this is being swapped. යාව මාරු කරලා තියෙන්නේ. හැබැයි ආන්නේ blocked කියන situation එක. So it is called swapped out and blocked. Now, is it only the blocked processors that is helping to create the crowdness inside the RAM? Right? Block කරපු අය විතරද RAM එක crowd කරන්නේ. එහෙම නෑ නේද? waiting ඉන්න කට්ටියක් settle කරගන්න පුළුවන් නේද? So waiting ඉන්න කෙනෙකුත් can be swapped to the hard disk as well. So when you swap a waiting one onto the hard disk, that is called swapped out and waiting. Right? Again, block වෙලා හිටපු කෙනෙක් RAM එකේ hard disk එකට ආවම we call it swapped out and blocked. Waiting වෙලා ඉන්න කෙනෙක් hard disk එකට ආවොත් we call it swapped out and waiting නැත්නම් swapped out and ready. ඊතෙන්දි waiting කියන වචනේ තමයි වැඩිපුර පාවිච්චි කරන්නේ swapped out and waiting, right? We call it swapped out and ready as well, right? Okay, මගේ මෙතන presentation එකේ පොඩි mistake එකක් තියෙනවා, right? But I'll talk to you from this point. මෙහෙම suspend කරපු කට්ටිය, we'll talk about the swapped out and blocked people. So the processors which are being swapped out and blocked later can be activated. ඇයි activate කරන්න? RAM එකේ තියෙන crowdness දැන් ටික ටික අඩු වෙනවා. Right? It's not crowded now. So that means operating system will see, okay, the people who are in the virtual memory now can be taken to the RAM again. It has enough space. So operating system can activate and ask the process one to come on to the state that he was before. So got a swapped out and blocked වෙච්ච කෙනෙක් activate කරාම එයා එන්නේ ආයෙත් blocked කියන state එකටම තමයි. Right? Not to the any other states. Right? Now, is that clear, people? The swapping process of the blocked ones. Right, perfect. Now, as I told you earlier, I told you the waiting people can also be swapped, right? This is how it happens. See? So this can be swapped. So it is called the swapped out and waiting, right? Ready එකේ ඉන්න කට්ටිය ඒගොල්ලෝ මම කියන්නේ waiting කියන state එකක් මේගොල්ලන්ට දෙන්න පුළුවන් කියලා. So මෙතන තාම අපි call කරන්නේ swapped out and waiting, right? So later, like we discussed earlier, once it is been activated, then again this can be taken to the previous situation, which is called ready. The ready state එකේ ඉන්න කෙනෙක් hard disk එකට swap කරාම we call it swapped out and waiting. And once it is been activated, we call it is now in the ready state in the RAM. So the same scenario happens, only the state is the different one. Block කෙනෙක් suspend කරාම swapped out and blocked. Waiting කෙනෙක් නැත්නම් ready කෙනෙක් swap කරාම swapped out and waiting, right? ඕනම කෙනෙක් activate කරලා we can take them to their earlier state, right? Okay, just a second, people. Right, now this is the same diagram that I had given to you in your book, right? So just go through that, people. Now you know what is actually happening. There are some additional details as well. So we are going to rehearse that on the next day. Right, now you know what is happening, right? So you can go through. This diagram is there in your book as well, right? So by next week, we are going to learn how to draw this as a story, right? So this diagram is called 7-state transition diagram, right? So in the examination, this is what they are asking, right? So it's better you know how to draw that and how to deal with those, right? And there are some new states, new transactions are there as well, right? May swapped out and block වෙලා mechanic swapped out and waiting වෙන්න පුළුවන් විදිහක් අපි පෙන්නලා තියෙනවා, right? So බලමු කොහොමද ඔය වැඩේ සිද්ධ වෙන්නේ කියන එක, right? So we'll discuss those things by next week. Right now we'll move to the gates part, right? Okay, so I'm going to move to that part, and people like අලුතෙන් ආපු කට්ටිය මේ පාර්ට් එකේ හිටියක් කමක් නැහැ, ගියත් ගැටලුවක් නැහැ, මොකද ඔයගොල්ලෝ මේ පාර්ට් එක මුලින් ඉඳලා cover කරගන්න ඕන නිසා, right? So you are welcome to stay, right? Otherwise you can leave because you don't know from the beginning, and others please don't leave, right? You have to stay with me, right? Let me end this one and take the gates part with you. Okay. So regarding the gates, we have learned about many different things. So very lastly, we discuss about how a K-map can be managed, right? And how that particular K-map can be used to simplify some expression, right? So these are the workings that we have done last time. So today, I'm going to show you how to simplify a POS from this particular K-map, using these particular K-maps, right? And when it comes to there, right, when it comes to here, now you know how to do the things. No problem, Nitni, no problem, right? Now, with this calculations, we know K-maps were used to simplify a SOP, sum of product expression එකක් simplify කරන්න තමයි අපි K-map එක පාවිච්චි කරන්නේ. But there is a way that we can yeah, Nimansa, it doesn't matter දුව. ඔයගලන්ට මේවා මුලින් ඉඳලා කරෙන්න ඕන නිසා netmi Nimansa leave වුණාට කමක් නැහැ. අකිල හිටියට කමක් නැහැ. මොකද බලාගෙන ඇවිල්ලා තියෙන නිසා, right? Clear නැති තැනක් තිබුණොත් මගෙන් අහන්න. හරි? So today we'll talk about how the things are going to right, Netmi, right? Okay, thank you. Let's talk about how the POS is going to solve with this place, right? So yeah, let me take a simple one, right? I'll do the example from a simple one first, right? Simplifying a POS using a K-map, right? So let me take an example. So this is the example number 1. I'm taking A bar plus B dot A plus B, right? It's a simple SOP, right? So now this has two variables, right? Which is A and B. So that means if we think about a K-map, we need a K-map which is a 2 by 2 one. One part is A and the other part is B, right? So in the very same way, we are going to define these places like this, right? Now the time for you to be very careful, right? How you are going to be careful. So you are going to put, or you are going to indicate A bar plus B term. We know in a POS term, it is an addition. If you consider a particular term that you can see an addition. It's just an addition. In an SOP, we know it's a multiplication. So to indicate the SOP, we use 1 inside the K-maps, right? And here, to indicate the POS terms, we use zeros in the K-map. That means you are going to put zeros for the particular POS term, right? And how we are going to recognize the cell, or how the cell is going to be named. Right now, we know we have named this K-map according to the SOP terms. SOP වලට ගැලපෙන විදිහට තමයි මේ ලියලා තියෙන්නේ. But then POS එකකට බිඳුවක් දාගන්න ඕනේ. So when you are placing the zeros, you have to consider the terms which are going to represent as an SOP with the opposite states. මොකද්ද මම කිව්වේ? අපි POS term එක දාන්න යනකොට බිඳුව දාන්න යනකොට, right? We got the first term as A plus B. Now this should be considered as A dot B bar. Did you got what has happened? A bar තියන එක A වුණා, B තියන එක B bar වුණා. Right? එතකොට ඔයා K-map එකෙන්, this is the place of the K-map. Right? දැන් තාම මේ වගේ ගානක් විභාගෙදී අහලා නැහැ. But I'm giving it to you. It is capable and it is possible. Right? So POS term K-map, or let's say cell name. Right? දැන් මම මේක මෙහෙම ලිව්වට ඔයගලන්ට හිතින් මේ වැඩේ කරන්න පුළුවන්, right? You don't need to write it and get these things, right? When you are plotting the zeros, you plot it carefully and correctly, then you will be getting the answer, right? But this is the logic behind this, right? So POS term and the relevant cell name. In K-map. Right? So POS term is A bar plus B. So the relevant cell name is going to be A dot B bar. Where you can find the A dot B bar? Right over here. So this is going to be a 0. Right? So that is how we represent A bar plus B in the K-map. So the next term is A plus B. We are going to represent A bar dot B bar. Right? So that means right over here.
අපි උඩ එකේ මේ A බාට නෙමෙයි ඒටනේ බාර් එකක් දැම්මේ මේ එක B K-map එකකදී B.
ඔව් නිර්මාණ උඩ එකේ කියලා කියන්නේ ඔයා කියන්නේ මේ මෙයාට නේද?
ඔව්.
ඒතර මේ තියෙන නිර්මාණ ඔයාගේ මේ දීලා තියෙන එක්කෙනාගේ terms දෙක මම ලියලා තියෙන්නේ. ප්‍රකාශනයේ තියෙන terms දෙක. ඒ කියන්නේ මේ දෙන්න තමයි මෙතන ලියලා තියෙන්නේ. හරි. එතකොට ඒක K-map එකේ මැච් වෙන තැන තමයි මම මේ එහා පැත්තෙන් ලිව්වේ. ඒතර එහා පැත්තේ ලියනකොට ඒ කියන්නේ මේ පැත්තේ ලියලා තියෙන්නේ. මේ පැත්තේ ලියනකොට මම කරේ මොකද්ද? A bar ඉන්නවා නම් එයාව A කියලා represent කරන්න. B හිටපු කෙනාව B bar කියලා represent කරන්න. ඒ කියන්නේ එයාගේ state එක change කරනවා. right? ඒ වගේම plus එක dot එකක් බවට ගන්නවා. මොකද අපි දන්නවා K-map එකේ තියෙන්නේ dots වලින් තියෙන ඒවා. නේද? SOP terms වලට අදාළ ටිකනේ K-map එකේ තියෙන්නේ. තේරුණාද නිර්මාණ? එතකොට ඒක තමයි A
හරි දැන් පැහැදිලි.
කෙනා A bar dot B bar උන්නේ. right? okay. so
ඒතකොට
now
මේකම
we are
ස්ටේට් චේන්ජ් කරන්න ඕනද අපි හැම එකම? ඒ කියන්නේ හැම ටර්ම් එකකම ස්ටේට් එක චේන්ජ් කරන්න ඕනද?
POS එකේ
plus
POS නම් තියෙන්නේ ඒ විදිහේ ස්ටේට් චේන්ජ් එකක් වෙනවා. මේ ඔක්කොම කරන්නේ මේ K-map එකට බිඳුව දාන්න ඕන තැන හොයා ගන්න. හොඳේ. හොයා නැතුව මේක පේපර් එකේ මේ ටික පේපර් එකේ ඇඳලා පෙන්වන්න ඕන දෙයක්වත් කරලා පෙන්වන්න ඕන දෙයක්වත් නෙවෙයි. right? මම මේ එක්ස්ප්ලেইন කරන එක කරන්නේ. right? ඔයා මේ ටර්ම් එක දුන්නම K-map එක ඇඳලා බිඳු දෙක දැම්ම නම් ඇති හරි තැන හොයාගෙන. හරි තැන හොයාගන්න විදිය තමයි මම මේ වගුවෙන් ඔයාලට පෙන්වන්නේ. clear?
හරි සර් clear.
right. So once you are done with the zeros, then you can fill the other places with ones. So this is going to be 1, this is going to be 1. Right? So for your information, Akila A bar plus B bar avot A dot B කියන කොටුවට තමයි බිඳුව දාන්නේ. Clear da Akila? Right. Okay, so yeah, it's better you indicate how things happen. This is this 0. And this is this. Right? So now what we are doing is we can simplify this, right? So how to simplify it? To simplify this, we have to group. So then POS එක simplify කරන්න අපි දැන් මේ බිඳුනේ. So that means we are going to group the zeros. So when you are grouping the zeros, same thing applies. Same rules are applied. Right? Horizontal and vertical විතරයි group කරන්න පුළුවන්. Then many number of zeros should be inside. Ones දාගන්න බෑ. මොකද දැන් zeros නේ අපි group කරන්නේ. overlap කරන්න පුළුවන්. right? එතකොට wrap around කරන්න පුළුවන්. right? ඒ ඔක්කොම දේවල් zeros වලටත් අයිති. එකම වෙනස තියෙන්නේ POS එක simplify කරගන්නකොට අපි zeros ටික තමයි අපේ groups විදියට අපි හදාගන්න. right? So how we are going to make the group? This is going to be the group. Right? So this group contains two things. නේද? මොනවාද මේකේ තියෙන්නේ? A bar dot B bar is there. Excuse me. A dot B bar is there. So that means B is the common one. Right? So for this group, B bar is the SOP term. Right? So this is the SOP one. So B bar indicates what? අපි මේ දැන් ලිව්වේ SOP terms වලට අදාළවනේ. B bar පොදුයි කියලා ගත්තා. එහෙනම් POS term එකේදී මෙයා මොකද වෙන්න ඕනේ? කලින් මේගොල්ලෝ මේ පැත්තට හැරුණා. දැන් මේගොල්ලෝ මේ පැත්තට convert වෙන්න ඕනේ. right? ඒ කියන්නේ මේ common term එක අපිට මෙතනින් මේක ගොඩ දා ගන්න පුළුවන්. right? දැන් බිංදු වලට අදාළව තියෙන terms දෙකනේ මම මේ පැත්තේ ලියලා තියෙන්නේ. ඒතර මේ දෙන්නගෙන් පොදු එක්කෙනා වෙන්නේ B bar. ඒතර A B bar වෙන්නේ K map එකේ cells වලට අනුව. එහෙනම් POS term එකේ පොදු එක්කෙනා වෙන්න ඕනේ කවුද? It's going to be B. People, is that clear?
POS එකත් වෙනම ලියන්න ඕනද common term එක?
නිර්මාණ තේරුනේ ආයහන.
ඒ කියන්නේ අපි SOP එක ගැන හෙව්වේ B bar කියලා.
ඔව්.
එතකොට මේ POS එක ලියන්න ඕනද? ඒ කියන්නේ ඕකේම අනිත් පැත්තනේ. ඒ කියන්නේ ඒක වෙනම ලියන්න ඕනද කියලා සෑහුවේ.
ඔව් ඒ කියන්නේ නිර්මාණ අපි දැන් මෙතනින් හොයාගන්නේ SOP term වල common එක්කෙනා තමයි B කියන්නේ කියලා. ඒතර අපේ උත්තරේ වෙන්නේ නිර්මාණ අවසාන උත්තරේ වෙන්නේ B. ෆයිනල් ආන්සර් එක වෙන්නේ B. එතකොට මේ උඩ අපි ලියපු මේ A bar plus B dot A plus B කියන එක්කෙනාගේ simplified answer එක වෙන්නේ B. ඒක තමයි අපි ඔය හොයාගත්තේ. තේරුණාද නිර්මාණ? මේ කියන්නේ මෙන්න මේක. A bar plus B dot A plus B equals B. Got it? Nirmana clear?
හරි සදන් clear.
Right. Right, let's write this down, people. Okay, one is done. How about others? Okay, anyone who is still writing? Right. Can we move, people? All right. So let's do some questions quickly, right? Let me check whether I'm going to give you the, yeah, I'll give you some questions so you can, yeah, before that, people, before that, I want you to do another thing. From this K map, which we have drawn here, write the simplified SOP term. දැන් එකේව තියෙනවනේ එකේව දෙන්නත් අරගෙන SOP term එකක් ලියන්න බලන්න ඕකේ simplified SOP term එක. What should be the simplified SOP term?
කේවත් බිඳුවේ වනේද?
දැන් බින්දු ටික අරගෙන අපි ලිව්වනේ POS එක නිර්මාණ. මට ඕනේ SOP එකේ simplified term එක. කියන්නේ එකේව ටික සලකලා simplify එක නා කවුද කියලා බලන්න. Nikini? Yeah, those are the terms. So what should be the answer? It is B. අන්න හරි. ඕක තමයි මට ඔයගලන්ට කියන්න ඕනුනේ. So it's the same answer, right? POS එකෙන් simplify වෙලා එන answer එකමනේ ඔයගලන්ට SOP එකේ simplify එක විදිහට ආවෙත්. නේද? මෙයාව simplify කරාම ඔයගලන්ට එන්නේ B කියලා. So it's a golden theory, right? SOP weva, POS weva, it doesn't matter what is the term, we are writing the same function. Ekama function ekata nan liyanne SOP එක හෝ POS එක, because you know we can derive a POS and a SOP from the same truth table. Ekama truth table ekata අපිට SOP and POS terms දෙකම අරගන්න පුළුවන්. We have done those things. නේද? අපි මෙතන කරේ. So this SOP term is equals to the POS term. They carries the same value. එයාගොල්ලන්ගේ expression එක change වෙන්න පුළුවන්, වෙනස් වෙන්න පුළුවන්. But they contains the same boolean value. Right? ඒ කියන්නේ මේ term එකට ඔයා truth table එක ඇන්දා, මේ term එකට ඔයා truth table එකක් ඇන්දා, it's finally it's going to be this truth table. නිතරම ඔය truth table එක තමයි ඇඳෙන්නේ. එකම output line එක ඔයගලන්ට ඇඳෙන්නේ. Right? So remember that the truth table is same. That means SOP and POS terms are identical regarding one particular scenario. Right? You can make එක අවස්ථාවක් නැත්නම් එක truth table එකක් සම්බන්ධයෙන් එයාගේ POS value එක identical SOP value එකට. දැන් අපි දැන් අද ඔය කරන්න යන එකෙත් මම ඔයගලන්ට ඕක කරලා පෙන්නනවා SOP and POS වල එන values කොහොමද කියන එක. So you can experience that. Right? Okay, we'll do some exercises. Right. So here we go. තප්පරයක් ඉන්න ළමයි බෝඩ් එක පොඩ්ඩක් රෙස්පොන්ඩ් කරන්න දුවියා. Simplify the following POS using K-maps. Right, so the question number 1. Right, so that is the first one. Right, so you can use this kind of K-map. And the second one,
සර් ඔතනින් කොමන්ට් ටර්ම් එකක් ගන්න බැරි වුණොත් කොහොමද?
common term එකක් ගන්න බැරි වෙන්නේ නැහැ. එහෙම බැරි වුණොත් තනි වෙනවා. Right?
නෑ සර් උඩ එකේ බලපුවහම මේකයි මේ මං කිව්වේ පළවෙනි එක්ස්ප්‍රෙෂන් එකේ දීලා තියෙන විදියට
මුලින්ම zeros ටික plot කරගන්න ඕන නිර්මාණ මෙතනට. මේ K-map එකේ කොටු
නෑ
හතරක්
සර් කන්වර්ට් කරාම තමයි මං කිව්වේ ඒ කියන්නේ අර අපි දැන් ස්ටේට් එක චේන්ජ් කරාම කොමන්ඩ් එකක් ආව නැති හන්ද බැලුවේ.
ස්ටේට් එක change කරාම මේ තුන් දෙනාටම comment එකක් එන්නේ
නෑ
නැහැ.
නේ හරි ඒක
එක විදිහට group කරද හැකිනේ. ඒක change කරලා plot කරලා ඉන්න. මේක
හරි
plot කරලා ඊට පස්සේ group කරගන්න. group කරනකොට change වෙනවා. Right, so this second one can be drawn in 2x4 matrix. Right, so you can draw the 2x4 matrix in this manner. Okay, try to finish these two. I'll
Sir?
give you, yes, do me and send me the answers. I'll give you 5 to 6 minutes. It's 111, like 116, 17. Let's discuss that.
සර්
Oh, Nirban.
සර් දැන් SOP ටික මාක් කරාම එක කොටු එකක් ඉතුරු වුණා. ඒ ඉතුරු එකට මොකක්ද කියන්නේ? කියන්නේ SOP තුනම මාක් කරන් පස්සේ zeros දැම්මට පස්සේ මේ එකක් ඉතුරු වුණා.
ඔව් කොටුවක් ඉතුරු වුණානේ. ඒතර zeros දාලා ඉවරුනාම ඉතිරි වෙන කොටු වලට එක දාන්න ඕනේ.
හරි සර්.
හරි.
සර් මට අර අතනින් පස්සම පොඩ්ඩක් කවුල තින්ද මාක් කරලා ඉවරයි මේ අර අන්තිම මේ
හරි. දැන් zeros ටිකයි ones ටිකයි මාක් කරානේ.
ඔව්.
දැන් zeros ටික තමයි ඒවා group කරගන්න ඕනේ. ඒතකොට අර එක ඒවා group කරපු එකම ඔළුවේ තියාගෙන එක ඒවා group කරපු නීති ටිකක් තිබ්බනේ. ඒ ටිකම ඔළුවේ තියාගෙන බිංදු ටික group කරන්නකො.
ඒකත් කරා සර් වෙනම අරගෙන.
හරි. ඒතකොට මේ බිංදු ටික group දෙකක් එන්න ඕන ඔයාලට. දෙකක් ආවද?
SOP එක POS එක කියලා සර්.
නෑ. POS එකට මට එවන්නකො කරපු වැඩි.
හරි සර්.
හරි. right okay. නිර්මාණ මේක group කරලා නෑනේ ඔයා. round කරලා groups ටික හැදෙන්න ඕනේ. කොහොමද group හැදෙන්නේ?
හරි සර් හරි අර කලින් එකේ වගේම group ගන්න
ඔව්
තියෙනවා.
ඔව් ඔව්. කලින් එකේ වගේම round කරලා group එක හදලා ඒ group එකකට තියෙන පොදු ටික අරගෙන ඒකෙන් පොදු පදයක් ගන්නකො එළියට.
සර් එකක් ගත්තා. A.B කියන එක.
හරි. එතකොට කොහමද ආවේ? එක group එකකට මොකක්ද ආවේ?
එක group එකකට අවසයි A.B බා කියලා එකක් ආවා. A.B කියලා එකක් ආවා. අනිත් එකට
නෑ. ඔව්. ඒතර ඒකේ පොදු එක ගන්න ඕනනේ.
ගත්තා. ඒ කියන එක.
ඒ කියන්නේ එක group එකකට ආපු පොදු එක මොකද්ද? Aද?
ඔව්.
අනිත් එකේ පොදු එක?
අනිත් එකේ පොදු එක සර් B.
අනිත් එකේ පොදු එක B.
ඔව්.
හරි. දැන් එතකොට ඔය එක group එකක ආවේ A. A අපි දැන් අරගෙන තියෙන්නේ SOP term එකට දාලාවනේ.
ඔව් සර්.
එතකොට එයාව A බා වෙනවා. හරි. අනිත් group එකේ ආවේ B නේ.
ඔව්.
එයාව B බා වෙනවා.
ඔව් සර්.
හරි. ඒතර වගේ අන්තිම උත්තරේ වෙන්නේ A බා එකතු කිරීම B බා. POS එකක් නේ අපි ලියන්නේ.
ඔව්. එතකොට සර් එක ආපු තැනක් තියෙන්නේ ඒකම තමයි.
ඔව්.
අපි POS ඒකම තමයි තියෙන්නේ.
ඒකම තමයි තියෙන්නේ. ඔව් ඔව් ඔව්.
හරි.
හරි. Okay, Nikini, I receive yours. Yes, yes, that is correct. That is correct. And yeah, how about this? Let me see. Let me see. Okay, okay. Oh, people, hold on. නිර්මාණ මගේ අතින් පොඩි වැරද්දක් වුණා. A bar plus B bar නෙවෙයි පුතේ. A bar dot B bar වෙන්න ඕනේ. මොකද A bar කියන්නේ එක ටර්ම් එකක්. B bar කියන්නේ තව ටර්ම් එකක්. එතකොට මේ ටර්ම්ස් දෙකක් අතර මැද්දේ තියෙන්න ඕනේ ඩොට් එකනේ. හරි. අපි දැන් SOPs ලියනකොට ලියන්නේ ඩොට් විදියට ලියලා ටර්ම්ස් අතර ලියාගන්නේ ප්ලස් එකක්නේ. POS එක ලියනකොට ප්ලසස් ඇතුලේ ලියලා ටර්ම්ස් අතර තියාගන්න ඕනේ ඩොට් එකක්. right? එතකොට වාගේ උත්තරේ වෙන්න ඕනේ A bar dot B bar වෙන්න ඕනේ. A bar plus B bar නෙවෙයි. Nikini, can you get the point? It's same goes with your answer dual. Because in a POS, in between terms, there is a dot.
සර් මම එවපු ආන්සර් එකේ ඩොට් එකක් තිබ්බන හරි නේද?
ඔව්. ඔයා එවපු ආන්සර් එකේ Nikini, I'm talking about the final answer. Ah, yes. Now that is correct, dude. Yes. Now that is correct. And yeah, in the second answer, dude, it should be A dot B bar plus C bar should be within the brackets, dude. B bar plus C bar එක brackets දාන්න. Otherwise, it won't show as a what we call a POS. Yeah, perfect. Nikini, both the answers are correct. Have the brackets to that. Nirmana. Oh, A bar dot B bar වෙන්න ඕනේ නිර්මාණ. ඒක හදාගන්න. Lalindi, let me see. Perfect. Yes, that is the answers, bro. Right, very good. Lalindi, please put the ones in the second K-map, duo. Ones miss karan depa. And Sachintani, let me see. Okay. Yeah, Sachintani, duo hari තෝරගෙන තියෙනවා. A bar and B bar එන්න ඕනේ. A bar and B bar අතර දුව there should be a dot, not the plus. අපි plus එක දාන්නේ දුව SOP තියෙනකොට. Right? POS තියෙනකොට terms අතර තියෙන්නේ dot එකක්නේ. මෙහෙම dot එකක්නේ තියෙන්නේ. So we use the dot. Then දෙවෙනි එකෙත් සචින්තනි A bar becomes A dot B dot C become B bar plus C bar. Sachintani, තේරුණාද කියපු එක? ඉන්න, right. ඔයා දුවගේ සචින්තනි එකක term එක ඇවිල්ලා තියෙන්නේ it's the A bar, right? Let me see. Yeah, it's the A bar. Anit group එක ඇවිල්ලා තියෙන්නේ B dot C. Now these are SOP terms, no? These are SOP terms. So what should be the POS terms? This is going to be A. And this is going to be what? B dot C, the POS terms is going to be B bar plus C bar දුව. අපි අර උඩ එකේ අපි terms ලිව්වේ මාරු කරලා. Right, so B dot C, we are going to represent it as B bar plus C bar. So the final answer is going to be A dot B bar plus C bar. Is that clear, Sachintani? Right, great. Hari, මම පළවෙනි එක කරන්නම්. To see whether you have got it correctly. Right, so they are saying A plus B bar. So if it is A plus B bar, K map, I need to find A bar dot B for this. This is A dot B. This is A dot B bar. Those should be the places where I have to plot. So A bar dot B comes here, A dot B comes here, A dot B bar comes here. This is going to be a 1. So how we are going to group this? These two can be grouped together, as well as these two can be grouped together. Right? So from this, what are the terms I have? A dot B bar, A dot B. So the common one is B. And for this, it is A bar dot B and then A I'm sorry, did I went it wrong? The first one, A dot B bar, A dot B, A bar dot B and AB. Oops, hold on. Yeah. Yes. මෙතන අරගත්ත එක වැරදි. මේක this should be A, this should be B. Right? So these are the SOP terms. මේ තියෙන SOP terms ඔයගලන්ට ඇවිල්ලා තියෙන්නේ. So what it should be the POS terms? A should become A bar, B should become B bar. Right? So the final answer is going to be A bar dot B bar. මොකද අපි කලින් K maps වල කරනකොට කරේ common term එක ගත්තා. ඒ common terms ටික pluses වලින් connect කරේ. POS එක කරනකොට කරන්නේ take the common terms, connect it with a dot. So the final answer is going to be A bar dot B bar. Right? දැන් ඔයගලන්ට ඕක හරි කියලා recognize කරන්න පුළුවන්. මේකේ SOP එක ලිව්වොත් මොකද වෙන්නේ? SOP එක අයිති වෙන්නේ මෙයා විතරනේ. So එයාගේ term එක මොකක්ද? It is A bar dot B bar again. So it's the same answer. Right? You should have that. Okay. Clear the maker? Tamai?
සර් මේ මං එවලා ඇති එකක් දෙවෙනි
බලමු. Okay. බලමු නිර්මාණ. අන්න හරි නිර්මාණ. Very good. Oh. A bar එක A වෙනවා. dot B dot C එක B bar plus C bar වෙනවා. හරියටම හරි. අකිල පුතේ ඔයාට ක්ලියර්ද මේක? සමහර විට පොඩ්ඩක් හිර වෙන්න පුළුවන්. right? If I go to the second one, all right, come on, Akira. Oh, A called with Yagan, I refer Karanda, it's got okay way. So AB bar, A bar, B bar. So the rest of the things are going to be A bar dot B, and it's going to be AB, right? So the zeros are going to come for which places? A plus B plus C means A bar dot B bar dot C bar. Right, so this is going to be A bar dot B bar dot C bar. This is going to be, oh, I'm sorry. This is A bar dot B bar dot C bar. This is A bar dot B bar dot C. This is A bar dot B dot C bar. This is A bar dot B dot C. This is A dot B dot C. Right? Then we are going to plot A bar dot B bar dot C bar, which is this. A bar dot B bar dot C, which is this. A bar dot B dot C bar, which is this. A bar dot B dot C, which is this. A dot B dot C, which is this. So the rest of the things are going to be ones, right? So how we are going to create the groups? These four will become a one group. These two will become a one group. Right? So this contains what? A bar dot B, A dot B. So the common terms are going to be I'm sorry, I'm missing another one. Yeah, this one. Right, so the common terms are going to be B dot C. And for this, there are four things, A bar dot B bar dot C. Oh, just a second, people, whiteboard gets stuck. Okay. So the next one is A bar dot B dot C. Next one is A bar dot B dot C bar. Last one is A bar dot B dot C bar, right? So the common term from this is going to be A bar. From this, it's going to be B dot C. So these are SOP terms. So the POS term is going to be B bar plus C bar. From here, POS term is going to be A. So the final answer is going to be A dot B bar plus C bar. Right? Okay, so that's brilliant. All of you have like gone with that answer, right? So in next week, people, I'm going to start the rest of the things of this. I'm not going to do the operating system at first. We are moved to the gates, and we'll see how sigma and pi symbols can be involved with this. And again, I have to show you how to draw the a shorter way or a shortcut to create the circuits from universal gates for SOPs and POS. Right? SOP POS දෙක ටක් කාලා universal gates වලින් අඳ ගන්න ක්‍රමයක් තියෙනවා. අර අපි මුලදී අඳ වගේ map කර අඳින්නේ නැතුව ටක් ගාලා අඳින්න පුළුවන් ක්‍රමයක් තියෙනවා. But it is only for POS and SOPs. Right? So a methods දෙක කියලා දෙන්න ඕනේ. Then after we can go for the past paper questions. Right? Okay, so I'm going to end the session from here, and I hope you don't have any questions. කට්ටිය මාත් එක්ක interact වෙවි දේවල් ටික කරගත්ත, that's good, right? Akila, you can contact me further, right? එතකොට clear කරගන්න ඕන ටික පුතේ, right? Yeah, so I'm going to end the session from here. So thank you very much, people. I'll meet you on next week for the very same time, right? So thank you very much. Okay, people. Right, okay. Have a nice weekend. Thank you.